Good day to you. This is Anna Galactic from Chico, California on the 19th day of January 2023. We have several things we'd like to do today, so we're going to rush through this with an outline and then begin. The first thing we need to do is complete the bootstrap sequence so that we get the dynamic sphere with the relation of time and space correctly, which so far we don't have because the numbers are going in 180 degrees from the surface of the 1/1 spherical surface of the universe. In other words, they go reciprocally out and in a 180 degree angle. That is incorrect. We had to do it that way in order to visualize it, and it is an appropriate way to visualize it, but you must now change your concept of in, because there's nothing in the sphere. The sphere is actually the surface, and therefore it's just an imaginary extension to say that as the shells go out, and they are parallel with the 1/1 shell, they go out towards infinity and never reach it. That gives us a closed space for the numbers going out into the universe. The interior of the sphere is imaginary, but the surface is not. And therefore, the reciprocal relationship between 2/1, including all the other numbers, 3/1, 4/1, and they aren't quantum counting numbers, they're linear counting numbers. This is the miracle of Max Planck's discovery. He did not express it this way, but it's time it was expressed geometrically correctly. We're going to complete that right now. But before I begin, there are several things that have come up that require immediate address, and I'm going to be giving at least one more lecture after this one today. The first one will be on the Dirac equation. It was a few months ago that I published an explanation of sorts of the Dirac equation, but it's purely mathematical, in order to introduce a method of reading these equations, such as the two forms of the Schrödinger equation, the Dirac equation, and the Einstein field equation, which I've covered in extensive detail. We're now going to get into the geometry of time-space. I've already covered the difference between time-space and space-time, but not completely, and we're going to get to that right now. The other thing that we want to address is Roger Bošković, and we will be covering that. Now, today I'd like to show you over here. I've learned that the mouse doesn't actually show up, so I'm forced to use this kind of a pointing system. I'd like to direct your attention to the Dirac lecture that I have a link for that right here. This is in response to a comment that I got on the Dirac lecture from a few months ago. I think it was 3 months ago, that I attempted to give a brief lecture on how to read equations like the Dirac equation. I got a comment with a suggestion that I might want to see a video by a man named Dennis Morris, who describes himself as a mathematician and theoretical physicist, so he's certainly qualified to talk about the Dirac equation. He has a series of videos that he presented, about 6 or 8 videos, I believe. I watched several of them, but I, in particular, watched the one that was recommended, which was an excellent recommendation. Dennis Morris does a superb job of very briefly and quite elegantly, I believe, expressing to a layman. It has to be from a certain angle because it's very difficult to explain these equations on a single vector, a single point of attack. To get at these, you're not going to do it. You're going to need at least 2 or more vectors of attack to understand any of these equations, any of them. Anything that has to do with special relativity, general relativity, or quantum mechanics, you're going to need more than one perspective on it to get it at all. But it can be done. I'm going to show you how to do that. We're going to start with the Dirac equation. It is our goal from now until the solstice to get an understandable meaning by which I mean, according to the Einsteinian principle, it needs to be teachable to a high school audience. That's an arbitrary limit. There is no lower limit. This could be taught to a 3-year-old, if not in its current form. That cannot be taught to anyone under the age of about 21, because you have to study calculus for half of infinity to even have a hope of understanding it at the explicit level at which these equations are given, which of course is linear algebra with calculus, the very hardest form of calculus, the very limit of what linear algebra is able to achieve to address cosmic space, which now includes quantum space. That's my discovery. And it ends the entire sequence of the grand unification theory, the theory of everything. All of those are shoved off the picture. I have it. And it's none of those names. It's geometry. As it's high time to get back to geometry. And so I've been detailed for that minor assignment from the higher-ups in the universe who are directing things here on Earth through rational logic. So that's the bracketing information, and now we're ready to begin. We need to complete the bootstrap sequence. I have given a series of 3 lectures on that, although you could think of it as just one that's not quite complete. This will complete it. And so we're now going to begin where we left off yesterday. If you haven't seen any of those lectures, I never assume in any of my lectures that you have seen any of my prior lectures. So you can always begin at any one of my lectures and get a coherent unit of presentation, that you don't need references. I insist on that because science is nothing if not the ability to summarize. Okay? And this is good for me too. It's good for anybody who forces themselves to do this. You may find out some flaws in your theory or your approach from simply trying to explain it. Because if you can't explain it, you don't understand it. Einstein is very famous for having said you have to be able to teach it to a barmaid. Now, I'm not sure he used the word barmaid. There's another version on this. But it's to someone without PhDs, without maybe much education. If you can't explain it to someone off the streets, then you don't understand it. Now, that's not true in technology, because it's not true in engineering. That's what the calculus is for, as we've covered, and that's enough information for us to begin. So to bring us up to speed so we can jump right into this and complete the sequence, what have I been doing for these past 3 lectures? We wanted to begin to explain a new geometry using a Euclidean approach. Every scientist respects this, and now, if you're a real scientist, your eyes are wide open and you are ready with your red pencil, because this guy had better stick to the system. It's ruthless in science, and this is the most ruthless, harsh part, is the proof sequence. So that's what I've been doing. What for? What is the goal? The goal is to define spherical geometry. That means to create a new space, and this is not what you would call empty vacuum space. It's a geometric space which you construct in your mind. The goal of science is to construct the right geometry in the mind that matches real space. That, of course, cannot be done with lines. And if you would, that's the whole problem, and the first thing that a scientist has to do when trying to solve something or make progress of any kind, define the problem. Polio wrote a very good book on that at Stanford, on how to solve problems in mathematics. We are integrating mathematics and geometry, which is normal. They are integrated. In fact, that was proved in my lifetime. The line is the number system, and that is science. Science exists on lines. That's why we use calculus in cosmic space, and that's why science has halted. and it's halted for 70 to 100 years at both ends of the spectrum, which I will tell you is in and out. So that's astrophysics, that's out. And in is quantum mechanics. And that's what we're trying to unify. I have. You can already see where the problem is. It's a dual problem. Everything is dual. Get used to that. And if you need, just check the previous lecture. And if necessary, the one before it, but I'll summarize it for you now. You're going to have to say everything twice to say anything at all, even to yourself. That's called duality, and it goes to consciousness. You're going to need to change your mind. And that's really what it's all about. That's evolution. Evolution occurs in the human mind. It does not occur biologically. There's no such thing as natural selection or evolution. And if you think so, you are in serious trouble. And to get out of that, read Tom Wolfe's book called The Kingdom of Speech. This is the last book he wrote. He's the man who wrote The Right Stuff and the Electric Kool-Aid Acid Test. The very top level of American literature came from the pen of Tom Wolfe, one of the greatest journalists who've ever existed on the face of this earth, and that's quite an exalted company. So Tom Wolfe is an American hero to me. And I just found out within the past couple of months that Tom Wolfe, one of my heroes, wrote a book just before he died that tears in half Charles Darwin. Actually, in certain ways exonerates Charles Darwin, whom I have always respected, and all the way from the 1970s when I fought against natural selection, and we lost. Ever since then, I have been looking for some way to just expose this extraordinarily dangerous charade, which now dominates science, from the biological cesspools. Men unable to regulate their own minds, unable to follow the course of science, just generate a lie, turn it into a mass deception, and teach it in the schools. There was a reason for that, though. We had a choice between Hitler and Stalin. And it's just a toss-up which one you vote for. And that was the choice. Natural selection, which I call the monkey meat theorem. And what was the alternative? The Scopes trial covered that. And you can see some very good actors in Inherit the Wind. And there's been a remake of that on the Scopes trial, which was just a monkey trial. But it had an enormous impact on the course of American history in science, because it decided the fate of our educational system, which if you know anything about our educational system, particularly in mathematics and physics, you already know, maybe more than you want to know, about the condition of our educational system, which is abysmal. But it could have been worse. Instead of having Darwinism, natural selection, evolution taught as God's own law, which it's not, it's Satan's own law, but there's actually something worse. Because the contenders on whose side I stood were the creationist research institutes, of which there were more than one, and I belonged to more than one. I was a Bible scholar at the time in my youth, forgive me. You don't need to worry about that. But that is my history with that horrendous notion. So Tom Wolfe is your way out of that trap, because I don't have time. I can't deal with that anymore. I would exhaust myself. And I can't afford that anymore, because I have the solutions in something that's equally important. We do need to know our origins, and you will have to take care of that in your own life. You're going to have to ask yourself, and you're going to have to answer the question, where are you from? Where's humanity from? Where's the ecology from? Where is life from? And how did this solar system come into existence? Yeah, it goes right to astrophysics. Right from biology to astrophysics. So they are related. But I can't cover that. I can't do everything. I tried. But in this area, the area of astrophysics, we're going to come at it from the angle of quantum mechanics. You may think, well, that's kind of going to the wrong end of the spectrum. I will show you that that is the correct end of the spectrum. This has to do with the nature of light. I think you know that. It has to do with the nature of electricity and magnetism. It has to do with the nature of the electron and the proton and the photon. And it has to do with the origin of universal space. The Big Bang. Well, that's a big problem, isn't it? Because nobody understands it. It's because it makes no sense. And the reason we will now explore. That's the bracketing information. That's 15 minutes. That's about par for the course with me. It's extraordinarily important to have the bracketing information on a scientific discovery or a discovery sequence or anything you're doing in science. Why are you doing it? Well, it's going to go down to philosophy and maybe even religion, but we don't do that. But we do metaphysics. Einstein did, and the men before him did as well. They explored metaphysics to give the bracketing information on why you're doing science at all. It's to get the truth. You can take that to the bank. And so, to complete our bootstrap sequence of universal space for the new spheric geometry, I now will very quickly recap what we've already done. We begin with a blank slate, just totally empty space. This is in your mind, with nothing and no attributes to space. We don't even know it's space. It's just it's an empty space in our mind. And then we draw the line, as we were taught. From that we deduce there are two endpoints to the line, and from that we deduce that the line is embedded in a sphere. Then we erase the line. But we don't lose the line, but we gain the sphere with the linear system embedded in it on the diameter. You could say radius. They're equivalent. The diameter is 2 times the radius, correct? So we simplify it to the radius. In the past, we've accomplished the unit circle, which has a radius of 1, so you get linearity into the system. We make the unit sphere with a radius of 1, so we get unity into a 3-dimensional system. Those are called the unit circle and the unit sphere. We will not want that, but it's easy to invert the system because there's a direct relationship between the radius and the curved surface, either the circle or the sphere. We've already learned that there is a mathematical relationship between the surface of the sphere and the surface of the circle. The surface of the sphere is computed from the equation that you can look up. It's 2 tau. It's 2 tau. When the radius of the sphere is 1, then the surface value, as I call it, which encompasses the concept of rate of circumference and area. They're very confusing taken separately, but if you give them one class term, then you can just refer to your notes to distinguish between the two if you have to, but they are the same concept. The circle has a surface value in what we call 2D, and the sphere has a surface value that's equivalent to that of the circle, but in 3D. And because that's a volume surface, we say that it's not circumference, it's area. That is incorrect distinction. So, their one thing is called the surface number, and that's my term. You will adopt it now because it's logical and better. So the surface value of the circle is tau. And so it's remarkable that the surface value of the sphere is 2 tau. But it's easy to invert those, and it's just a question of which one you want. Do you want the circle, which will then relate the result to the sphere, Or do you want the surface value for the sphere, which then will relate to the circle? Well, with the composition, which is geometric, we have a 1 to 2 relationship. The sphere has a value of 2, and the circle has a value of 1. That is miraculous, and you'll see that in the upcoming sequence. That's where we're going. But to complete the thought on what we need numerically, we need to invert the sphere. That can be done on the standard equation for the surface of the sphere based on a linear 1 for the radius. You can invert that because the surface value of the sphere is irrational. We can't use that. And in the bootstrap sequence that we already went through, we found out that the surface value of a sphere in the universe is 1, and that is rational. But where did the relation go? It was inverted. We took the 1 off of the radius and put it onto the sphere, so the sphere is unitized, and that is the true unit sphere. The one that we call the unit sphere is the linear algebra approach to the unit sphere, whereby you're forced to put 1 on the radius if you want to do anything with the sphere, even though it's all going to be irrational, and that is the problem. We first invert that. We don't have to. We already have. And how do we do that? When you start with multiplicative space instead of additive space, you switch from the line to the sphere. I proved that. So it's actually proportional space is the space that the universe recognizes. It does not recognize directly linear space. We do. When we look at a star, we're looking on a straight line, and that's been proved that is a straight line. It's called the flight of the photon. So there is linearity in the universe, but it's somewhat illusory. And that is a paradox. It is actually the quantum paradox. Stated in a way it's not commonly stated, is that the fact that that photon goes directly from the star to your eye, that's impossible. That cannot happen, but it does. And that's quite a paradox, that it can't happen, but it does. And nobody can explain that, and Richard Feynman says that nobody ever will, because nobody can possibly understand that. Well, Richard Feynman is dead, along with the people that he murdered in Hiroshima and Nagasaki. He had a nervous breakdown from that, and then he took up drinking and smoking so he could end his life in some kind of comfort. But he was responsible in part for the atrocities in Japan. So, that's Richard Feynman. And this to Richard Feynman, for we can't understand it. Yeah, we're going to understand it right now, pal. I really love and respect Richard Feynman. But as a scientist, I have to be ruthless. He was ruthless in saying nobody will ever understand it. That's incorrect. You can't do that. You're not allowed to say something like that in science. He took a big chance by saying that. He thought he was on safe ground. So did Niels Bohr. Well, Stockholm agreed with him in 2022, told Albert Einstein to take a hike, and gave all the money to the Niels Bohr people to solve an old man's fight, which has taken over the minds and souls of anybody who talks about quantum mechanics. Today, they think they're talking about reality. Well, that's actually pretty ironic, because I'm going to show you what's real about it, so that you understand it, and you'll be one of the first in history to ever understand quantum mechanics. All right, and then you're going to understand the Big Bang and the whole universe, if you got the right stuff. All right, so where we left off, let me complete the former sentence. Where did we get the numbers from? Well, if you decide to make the edge of the universe infinity over 1, and the center of the universe, this is the universe in your mind. It's not necessarily the real universe. It's called a geometry, a geometric construction, which nobody's ever tried. Nobody's ever tried this. Well, I'm trying it. I already have. I'm just giving you the results. When you do put 1 over infinity at the center and infinity over 1 at the edge, several miracles occur, but we're just going to concentrate on one. It generates a number system. And now we turn to Max Planck to get the index of the number system. Because in multiplicative space, the center of that space is 1. The center of linear space is 0. We can't use that. That's what's causing all the problem. That's because it's linear. And that is an operator. The line, when you draw it, has an operator. And there's only one. We were taught that there were 4 operators. There are 2. And one of them is addition. And that's one of the only 2 operators at the elementary level. And that we were taught incorrectly what those are. Add, you can't get that wrong. Add works perfectly on the line. It's closed, and you don't need subtraction. That's an illusion. We have a convention of negative numbers. But strictly speaking, that's all you need are the negative numbers. Now you're just using add. And if you think you need to subtract 5 from 3, you're wrong. To do that, there is no subtraction. There's only addition of quantities. So there's only the operator add. There is no subtraction. It's equivalent. So I should be saying 2 things. I'm only saying 1, so I'm wrong. If I say there's no subtraction, but I said it that way to get you to wake up. Because there's only one other operator. What is it? Multiple choice. Is it multiply? That's A. Or answer B. Is it division? What's your answer? Everyone would say multiply. Wrong. It's division. And now for your second question, so I can complete the thought on, I just said it's division. Is that correct? A or B? Is it division or is it proportionality? Every mathematician would say it's division because that's what he teaches to his students. Wrong. It's proportionality. That's a synonym for division. Except it includes multiplication, and that's why you say proportionality. It's multiplication and division with a balance point of 0. I'm sorry. I knew I would do that if I went too fast. I'm going too fast. I'm trying to squeeze this down into 40 minutes. It's not going to work. These are going to be 1-hour lectures from now on. I just know it. I'm sorry. I would prefer to make these 40 minutes. I can't. I have to go an hour. That's my cycle. All right. So we have proportionality, which is division and multiplication on the multiplicative identity, not the linear identity, which is additive identity, which is 0. In spherical space, there's no such thing. Okay? So that leads to an interesting problem retroactively from what I said before, that linear space is embedded in spherical space. I stand by that. I have proved it. But you can see that our concept of the line has a number in it that doesn't exist in spherical space. It's 0. Well, there's a lot of other numbers on that line that don't exist in spherical space. They're called irrational numbers. And the curious thing about 0 is that it's super irrational. It's the center point of irrationality because the line is irrational. I'm going to show you that there's a better term for that straight line that's embedded in the sphere. It's not necessarily irrational, and we'll get to that. That's very important in order to get computation from the spherical number system, because you're going to have to translate it back to linear numbers, because those are the only computable numbers, are linear. We know that from circuit logic, which uses a 0-1 binary basis. 0 only occurs on the line. And so binary is a linear concept. We're going to need binary which means we're going to need the 0, 1 system, which means we can't get rid of the line. But there is a very interesting rule that governs that. That is the conversion from spherical space back to linear numbers. That has to be done on the last step, or you don't have computational numbers. Very serious paradox which I solved. So to continue with our sequence to get the full number system, we call in Max Planck, but we're not done making the universe. If you find the center, which we did with the antipodal theorem, we can now use the center and the edge, which we also discovered from the antipodal theorem, to make two numbers in proportion. That's 1 over infinity, proportion infinity over 1. What happens when you multiply them? That makes 1. So you put them together into one number. And now you have some kind of bracket, either curly braces or square braces or round braces. There's several terms for these three ways to embrace more than one number. You can choose whichever one you want. For this, I use what are called curly braces. There's several different names for this kind of construct. It's just a notational system. There's different terms used in Europe and England than we use in America. Doesn't matter. It's just a language problem. You can use anything you want. You can make up your own notational system. But you're going to need something to make two numbers make one number. To make two numbers make one number. Right? That was tried with complex numbers. That's all passé. By the way, in the Dirac equation, that's what really foils it. And Dennis, I think it's Dennis Morris. We'll get to that. In the next lecture following this one, we're going to cover the Dirac equation, which deals with complex numbers. But that is an attempt to use two numbers to make one number. It doesn't work. But this does. And now we call in Max Planck in just a moment. First of all, we have 1 over infinity at the center, infinity over 1 at the edge. We say that infinity means imaginary. You can't reach it. We're saying that as a postulate. So infinity is something you can never use, ever. We're going to put it outside the system. But what nobody ever realized, if you're going to try that, you're going to have to put the dual infinity outside the system. It puts itself outside the system on unity. When you multiply them together with our new definition of infinity, that it's the only imaginary space you're ever going to need to know about, because we're kicking it out right now, because it's imaginary, you multiply 1 over infinity times infinity over 1. That leaves 1. That's the sphere. And that's the center of the universal space. It's still in our heads, but now we call in Max Planck, who says you have a match on physics. It's called the quantum shell system. And here's how it works. It's with parallel spheres. He showed from the wavelength frequency relationship that the lowest counting number is 2. But if you just say 2, you haven't said enough. It's 2 over here and 1/2 over here. So do it whatever way you want. But you have 2 and 1/2. That multiplies to 1. Well, that's consistent and closed then. We have a closed number system for this space. Where are the numbers? The frequency beginning at 2 is a concentric sphere. The next one is 3, and there's nothing in between these numbers. That's miraculous. That means we have a counting system for universal space. It's the only one. These are called quantum numbers. But there's a catch. You're going to have to split your mind. When you conceive of distance going out, it's going out in all directions at once. This is the integral line. We'll cover that much more extensively, but this is very, very fast. I hope you realize it's hard to do this fast. I hope you can keep up. If you can't, go back to the last lecture. If you need more, go back to the one before that. But I'm summing it up so you can have it all in one place. You have two numbers, one at the center, one at the edge, and now you have a new one, a sphere with a value 1. Just so you know where the line is there, the radius is 1 over 2 tau. And that's where all the irrationality is. It's on an infinitesimal line. We'll come back to that. This is the calculus in geometric space without the calculus. It's the integral space. These are the integral numbers. And you notice so far they're all rational. Even 1 over infinity is rational. It's just you're with one special rule. You can't reach it and you can't use it. It's outside the universe. And that raises an interesting point. Pardon the pun. But the center of the universe is the same as the edge. In terms of what it is, it's imaginary. So both the edge and the center are imaginary. That leaves only one reality, the sphere. The spheric surface with a value of 1, the multiplicative identity. That is not the multiplicative identity. It is, but you're saying it wrong. It's the proportional identity. This will come back to solve everything when we apply it later. This is the basis of truth in the universe. Now we call in Max Planck. We don't have an index. Here's what index means. In linear space, you get the 0 and 2 infinities. The 2 infinities add to 0, right? What are you trying to measure? Linear separation. What's your index? 1. From 0 to 1 is your index. What is it in multiplicative space, which I'm just using the conventional term? It's proportional space. The identity is 1. That means that 1 is the lowest number in the universe. And that is true, but something needs to be added because you might object, and reasonably so, what about 1/2? That's less than 1. That's true. And here's how that works. If you say that the counting numbers go out, but the fractional numbers go in reciprocally, you can make a case for that, and that closes the system for multiplication and division. That means it closes it for proportionality, because now all the fractional numbers are going in to the center of the sphere from the surface to the proportion that the counting numbers are going out to the edge, and neither one of those sequences reaches either edge. That means the system is closed for multiplication and division. Now, Max Planck stepped in the year 1900 and announced, unbeknownst to himself, that he had discovered the counting system for universal space. In other words, a physical counting system based on energy. We're going to need that because that has time in it. And how did he do that? Wavelength times frequency equals light speed. We're now going to use that. What is the lowest frequency? It's 2. What's the highest fraction? 1/2. There's nothing higher between 1/2 and 1. It goes directly from 1/2 to 1 to the proportion that 2 goes directly from 2 to 1. They converge on 1. And so 2 times 1/2 equals 1. You now have a 2-component number system for the universe. And all numbers are 2-component numbers. And the spherical numbers all are 1. Every single number in spherical space is 1. Numerically. But the components change. And so the lowest number, which corresponds to 0 in linear space for the additive identity, the multiplicative identity, as we call it, is not 0. It's 1. And that means it's the center of the space. So now we have two notions of center. Right? That's where we left off in the last lecture. Now we're going to finish it. We've come to 40 minutes. We're going to go 20 minutes and finish this. When you realize that the index is 2 1/2, you have a split number, a two-component number that begins the counting number system of spherical space. And now you have an infinite number of rational numbers. However, the limit, we have not yet decided if there's an infinite number of them. You could say it either way. Our definition of infinity was predicated on a spatial conception, not a numeric one. And this leads to an interesting, I'll call it a semi-paradox. I'll just present it to you, but I've already answered it, and I'll answer it again now. Is the number system finite? Yes and no. It really doesn't matter. It's really kind of a parlor question. The universe is closed. Spatially, physically, it's finite. So that much is true. But are there an infinite number of rational numbers? That would depend on the circumference of the universe, right? In other words, as we approach physical infinity, getting a higher and higher counting number, is there a limit to that? If there is, it means there's a limit to quantized energy. That actually would be the energy component of the universe, if there is an upper limit to that. Well, if the universe is finite, there is an upper limit to energy, which means that there is a highest frequency and a lowest frequency, but it never reaches zero, and it never reaches infinity. Right? So far, so good. It's closed. We've gotten rid of all the problems, but now what does it mean? That becomes very interesting because we have no time in the system yet. It's purely spatial. That's what geometry is. Not anymore, it's not. This is a two-component number system, and I'm just going to give it away right now. Just accept this for now. We're going to prove it. But the two components, one is time, the other is space. Both of these are written as fractions. And so the unity number for time and energy is 1. That makes sense. These two numbers, time and space, multiply to 1 every time. They're the only numbers that exist. Are two component numbers that multiply to 1. This is what Albert Einstein taught us, and that's what Maxwell, I always get Maxwell and Planck confused for some reason. That's what Planck proved. But Planck actually predated Einstein, so this is really fascinating, isn't it? Well, I hope it's fascinating to you. And now we need to get energy onto the sphere. But first, let's complete the spatial conceptualization. We have a surface called a sphere, which is the center of space. Now, we haven't proved that yet because we haven't defined what the numbers going in represent. I've suggested that it's time, but that makes no sense. It's because we're doing what Albert Einstein did. We're trying to linearize time. We don't want to do that. We want to leave the universe to decide that for us. What Einstein discovered about time-space relation is that they're orthogonal. I'm now going to show you where that exists physically. When you postulate that the counting numbers going out are spherical shells, you're totally consonant with microphysics, and so you're fine doing that. That describes the electron orbital shell system. They're concentric spheres. Right? That's true. So far so good, but now we're not too sure about the reciprocal numbers going in. We're conceiving them as halfway to the center, and then 1/3 of the way, 1/4, down to the lowest number before the imaginary infinitesimal, which is 1 over infinity, which cannot be reached. That is the actual center. Is imaginary. You could say that it exists. You could say that it doesn't exist. If you say that it doesn't exist, you're correct. But you may remember that in a linear approach, you have to have some number at the center. Well, we have a number at the center, we just can't use it. We've already used it to make the universe. It multiplies with the edge to create real space. That is the universal relationship for numbers. If you're going to use numbers to compute cosmic space, you have to do it this way. It's blueprinted into your mind already. We've proved that, but you're going to have to figure out how that actually constitutes a proof. When and as you do, you'll begin to evolve. You're going to start using your onboard system for spherical vision and mathematics, and that's where we're going. So, you have the surface of the sphere, but you see, you actually can't go into it. It is what is inside the sphere is the center. That is imaginary space. That's why the black hole does not have a singularity at the center. And that's why the Big Bang is not a singularity. Because the singularity in both of those constructions is linear zero. But it's not linear zero at the center of anything, if we're right, and I am. It's a sphere, which cannot be penetrated. And Roger Bošković proved that back in the 18th century. And he used it to construct a better mechanical universe than anybody since has been able to produce. And his work was forgotten, not completely though. It wasn't just rediscovered by myself, but this kind of information is really unwelcome to linear algebraicists. They're too lost in their numbers. And by the way, if you need some information on that, Dr. Sabine Hassenfelder's book, Lost in Math. They're hypnotized. That's what she says. They're mesmerized. They love the beauty of their numbers so much they've blinded themselves to reality. That's no longer possible now that I'm here. I'm going to bring us out of it. I'm doing it right now. So the center of the universe is a spherical surface, but that surface has no interior. What does it have? It has a surface that we haven't used yet. It's a surface with a value of 1. When we have reciprocal numbers in proportional numbers in reciprocal relationship, we get numbers that fill the entire space to the imaginary center and edge. Right? But you can't get to the center because it's an imaginary center. That's the inside of the unit sphere, which we've redefined. The unit sphere has a surface value of 1. And the irrational linear system is on the radius. And that can be extended. You can recreate 3D and 4D space from this system. You can use any of the Clifford algebras to create any kind of linear space you want from the spherical system using the method that I'll show you. But we're not going to need it. This is integral space. This is the space that physics needs to compute in. And it begins with Max Planck's discovery of the index of spherical space. The shells going out are counting numbers. But the numbers going in are not going in. They're going perpendicular on the sphere. And now we inject the sphere with energy. And this occurs 1 Planck unit of time before the Big Bang. And this is the true Big Bang. It's not a Big Bang. It's a big event. You can say big if you... Why not just go along with it that far? The Big Bang is bullshit because it's incomplete. But the big event is geometric. And that's where everybody needs to begin, not just me and you. Everybody needs to begin there, not just I and you. So when you do begin this way, now you can see that going out in a straight radial line in all directions, that is the integral line, by the way, in spheric space. The real line, which is two parts, the radial line, which you can say is going out, although that's a direction, gravity actually goes in, and that is the definition of gravity. It's the radial line going in. That's a conceptualization and a condensation, but we're going fast. We're going to cover this in extraordinary detail from now until the solstice. About 6 months away. About 5 months. Whatever. So the numbers going out are perpendicular to the numbers going in. They don't go in the same sense. That's an artifact from our concept of linear space, which is 180-degree valence. The universe doesn't use that, except when a black hole explodes. And then you see the linear jets. But that's really the first straight line that the universe uses mechanically, is at the supergalactic level, or the galactic level, however you want to conceptualize that, extrinsically or intrinsically. But this does solve the equation of the universe and the equation of the supermassive black hole. It also, as I'm going to show you in the next lecture, beginning with the Dirac formula, this solves the quantum paradox from the inside out so that you will understand it, and you can do this to Richard Feynman. And it begins here by realizing that 1/2 is on the sphere, to the proportion that 2 jumps from the surface of the sphere to a new concentric sphere with nothing in between. That's called the quantum jump. That's incomplete because there's a reciprocal action. Reciprocal, yeah. Newton. For every action, there's an equal and opposite reaction. That's a linear conceptualization that Newton was using. The universe doesn't use 180-degree orthogonality. It uses 90-degree orthogonality. That has a physical basis. That exact right angle is physical at the quantum level. And that's what we're getting to. Extraordinarily deep, because it's extraordinarily explanatory. As the counting numbers making spatial distance goes out spherically in jumps of counting numbers, the fractions, which are 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, all the way to what's happening? You're dividing. When you go out, you're getting larger and larger numbers. Beginning at 1, the lowest number in the universe, equivalent to 0. But it's the multiplicative 0, which is 1, because all the numbers multiply to unity instead of add to 0. And that redefines the whole number system, which I've proved are linear numbers in rational relationship. That's a miracle. That's a pure miracle. And if the Nobel Prize is given out in any form of righteous way, I will get it in 2020, whenever. They don't give it to someone right away. They wait a few years to see what happens. But if you die, like what happened with Henrietta Leavitt, and you don't get it. They won't give it posthumously. Well, fuck Stockholm. They're too close to Copenhagen anyway, if you know what I mean. And this is Copenhagen under my lip. Oh, I'm human. I'm human and I'm miserable just like you. But I use drugs to make myself happier. Well, you think that makes me a good scientist? No. It doesn't interfere, but it makes me a better human. I mean, until I have to face my creator. I'm sure he wouldn't like me having snuff under my lip. But I told you, I'm human. So that's Copenhagen and Stockholm. See those probably already getting cancer. Oh, whatever. I don't care. I'm ready to go anytime. All right, that's enough. 54 minutes. I hope you're enjoying this. I certainly am. We have 5 more minutes. Let's complete this. So far we have a geometric sphere. It's not moving. Well, we have to make it move or we don't have the universe, because the universe is pure energy. You could say that. Einstein did. So you're on good ground. The universe is made of energy. Well, that's motion, which is time. The static sphere of pure geometrical construction has no time anywhere. Well, that means that our system is incomplete. We need time, because we need motion, because we need energy. How does energy enter the universe? As soon as the sphere starts to rotate. That's called angular momentum. And those are the fractional numbers. They describe angular momentum on the sphere. Here's how it happens. The sphere is just sitting there. Now it's struck with a torque force. You could say that's God, whatever you want to say, but it comes from somewhere. Sure came before the Big Bang. It came at the Univex event. The first event, that's an event. That's in time, not space, right? So time is extraordinarily peculiar, which is why we don't understand angular frequency, angular momentum, angular velocity, omega, anything in this special relativity or quantum mechanical constructs that deals with time. They're dealing with the sphere. They're dealing with the surface of the sphere. They found out late, and we're going to find this out from Paul Dirac's lecture, right from the mouth of the master, that it goes deep very fast, but we're coming up on an hour. I don't want these to go over an hour because I don't want to wear myself out. We have a lot of work to do today and until the solstice to rewrite all the equations so they can be understood. And we're going to begin with the Dirac equation so we can get right to the Einstein field equation. And from there we'll get into space-time and turn it right side in, because space-time, the way Einstein formulated it, is necessarily, no fault to his, it's inside out. That's why you have a hyperbolic space with asymptotic photon land with 3 space-time intervals, and that just, I'm afraid, can't be understood. It doesn't work. You failed. We're going to get it right. And so that is 57.5 minutes. That's good. We'll be back after I have some lunch. I'm going to take a shower. I'm going to shave. I'll probably go out and get a haircut. You can see it's about time. Look at that. Well, you know, poor people don't get haircuts. That's why hippies let their hair grow. One reason. They didn't have enough money for a haircut. By the way, in Kiev, they give themselves haircuts. They don't have barbershops there. They clip their own hair. Someone in the apartment or someone you know has one of those shavers. Everybody knows about it. They share it. They shave each other's head. That's why they always have close cropped heads. Save money. If you're trying to eat, that's a good idea. Well, so am I, but I need to do this first. Don't worry, I'm surviving. You don't need to send me money. I won't take it. But I do want a reward, and here's to close this out since we have 1.5 minutes. I do need your help. I am going to beg you just like everybody else on YouTube. I'm supposed to beg you for something, or what am I doing out here? Well, I figured out what to beg you for. It used to be just, I'm begging you to listen. Steal this. I don't want my name attached to this. I mean, it'd be nice, but I don't care. God knows. But you can steal this. Just wait for me to die or just go off the air. You know what happened to me? You take a chance. Hey, I just discovered spherical space. Just give everything that I gave you and put your own name on it. You'll get the Nobel Prize. But here's my begging request. You know Dr. Sabine Hassenfelder, of course, and if you don't, you should. Read her book, Lost in Math, then you'll know what's wrong with physics. I'll tell you the answer. She can't, but at least she'll explain the problem. It's mathematics. No. Yeah, it's always mathematics. By the way, this is good news for the little children, so if you need any incentive to help me get in touch with Sabine Hassenfelder, do something. Reach out to her. Give her my name. Give her the address. Just say this crank, this kook, this old man in Chico is barking up a storm. Maybe you want to look at this, Sabine. Offer her some money. Anything up to $100, she won't accept it, but if it worked, anyway, kiss her ass, do whatever you want, don't threaten her. She's busy, she's a good woman. She's at the head of the physics class right now. I need her help. I need her to look at this. But not to make money. I'll give you the money. If I get any money, I'll give it to you. Get me in touch with Sabine. That's 1 hour. We'll be right back. Stay tuned. This is Anna Galactic, bringing you the secrets of the universe. Well, when I first began, I didn't know it would be this far. The secret of the universe. We'll be right back.